Determine order and magnitude of symmetry. This is a check. Students, please go ahead and determine whether each figure has rotational symmetry, and if so, locate the center of symmetry and state the order and magnitude of symmetry. Teachers, please pause the video now. So in this first figure, figure A, it does have rotational symmetry about its center, and it has order 2 because when you rotate it, it takes 2 turns to get back to the original orientation. So its magnitude is 180 degrees. Figure B, no matter how many times I rotate it less than 360 degrees, there is no angle measure that will map it back onto itself. So this figure B does not have rotational symmetry. Figure C, it is an equilateral triangle. That's what those tick marks mean, that they are congruent. So if we rotate it about its center point, then it does have rotational symmetry. It takes 3 turns to get back to the original orientation, which means it has order 3, and its magnitude is 360 divided by 3, which is 120 degrees. Question: did you get this correct? If so, yay! If not, do you understand where you made your mistake, and can you fix it? Here is another check. Which figure has point symmetry? Justify your answer. Teachers, please pause the video and allow your students to complete. So the rectangle has point symmetry because it can be rotated 180 degrees about its center so that it maps onto itself. Figure B did not have rotational symmetry, so it cannot have point symmetry. And figure C had a magnitude of 120 degrees, but 120 is not a factor of 180 degrees. So it does not have point symmetry. A pattern has translational symmetry if it can be created by translating a figure or group of figures without using a reflection or rotation. So you see in this example, the red figure on the right side is being translated according to those 3 vectors to create the blue figure, the yellow figure, and the green figure. Tessellations often have translational symmetry, but patterns that are not tessellations, like this sun pattern, can also have translational symmetry. So if you look, if we took the group of first suns and we translated it according to this vector, we would get this second group of suns. If we did it again, we would get this third group of suns. So it has translational symmetry. Determine whether each figure or pattern has translational symmetry. If so, draw the translation vectors. Explain your reasoning. So if we look at this first picture and we look at this yellow figure here, if I translate it down, do I get this blue figure? No, it looks like the orientation of this shape, this yellow shape, has changed. So I'm going to make a conjecture and say that figure A does not have translational symmetry. Let's look at figure B. In figure B, it looks like if I translate according to this vector, then I create the 3 hexagons that are closest to that original hexagon. So it does appear that this tessellation, this pattern, has translational symmetry. So in figure A, it does not have translational symmetry. The top left figure has been rotated to create each additional figure. My conjecture was correct. This hexagon pattern is a tessellation, and the top left hexagon can be translated in many directions to create the tessellation. Check. Determine whether each pattern has translational symmetry. If so, draw the translation vectors. Explain your reasoning. Teachers, please pause the video now and have the students check. Yes, so in this example, if the top left and center left squares are grouped, then these squares can be translated down and to the right, or translated to the far right. If this pattern is extended further, then the squares can also be translated up, translated down, or translated up and to the right to continue the pattern. So this top left figure can be translated down, to the right, and then to the right and down to create the other shapes. So, just like our hexagon example, this figure has translational symmetry.